A bullet of mass m and charge q is fired towards a solid uniformly charged sphere of radius r and total charge plus q. If it strikes the surface of the sphere with a velocity u, find the minimum value speed u so that it can penetrate through the sphere. Neglect all resistance of or friction acting on the bullet except the electrostatic force. Now what is happening? If I consider this sum, in this numerical, if I consider that the entire sphere is charged, okay, and there is a bullet which just enters the sphere with a velocity u, okay. Now this bullet also has a charge of plus q, okay. This bullet also has a charge of plus q. Due to the plus q on this sphere, okay, due to the plus q on this sphere, this bullet will be repelled and it will experience force in the opposite direction, okay. It will experience force in the opposite direction, okay. Since it is experiencing force in the opposite direction, which is not uniform, it is varying, okay. So what will happen once the bullet enters the sphere? Once the bullet enters the sphere, due to the repulsive force, the acceleration, since it is in the opposite direction, the velocity will go on decreasing, and at the center, since it experiences maximum force at the center, okay, it will gain certain minimum velocity at the center, and after it crosses the center, it will again be repelled, and now it will experience force in the right hand side direction, okay. So again the velocity will go on increasing, and it can penetrate through the entire sphere. So the critical point over here is the center, okay. So the critical point over here is the center. Now I can say that since there is no external force, okay, since there is no friction force, no air resistance or anything, I can say that let this be the position A, let this be the position B, okay. So I can say that the total energy in the position A will be equal to total energy in position B. The total energy consists of kinetic energy at A plus potential energy at A is equal to kinetic energy at B plus the potential energy at B, okay. Now if I say that at the critical, if it still has certain velocity, if the bullet still has certain velocity in the right hand side direction, then it can easily cross. So basically the velocity should be greater than 0, okay. So the velocity at the center should be greater than 0. For the solving purpose, at the center we will take velocity as 0. Kinetic energy at point A is equal to half mu square. Potential energy at the surface, now the potential at the surface is, for a spherical conductor, it is given as kq divided by r. So it is equal to kq divided by r, okay. This is the potential at the surface, into charge will give me the potential energy at point A, okay. Into charge will give me the potential energy at point A. Potential energy at point B will be equal to 0, okay. Kinetic energy at point B will be equal to 0 plus the potential energy at the center. Now how is the potential energy given at any given part, okay, at any given distance? Let us say I am taking a point C. The potential at this point is given as kq 3r square minus r square divided by 2r cube, okay. This is the formula of the potential at any distance r from the center of the sphere, okay, for a volumetrically charged sphere, okay, which is equal to kq divided by capital R. Now small r is the distance from the center. At the center, small r will be equal to 0. So it will be equal to kq into 3r square divided by 2r square. So kq into 3 into kq into 3 divided by 2r, okay, divided by 2r. So it is equal to kq divided by r into 2 by 3 into the charge will give me the potential energy. So basically it is equal to half mu square is equal to okay, it will be equal to 3 by 2, okay, not 2 by 3, okay, it will be equal to 3 by 2. So it will be equal to 3 by 2 into q, okay. So it is equal to half mu square plus kq square divided by r is equal to 3 by 2 kq square divided by r. So when I subtract this half mu square, when I shift this on the right hand side, it will be equal to 3 by 2 minus 1, which is equal to half kq square divided by r. So in this case 2 and 2 will get cancelled out. If I substitute the value of k, it will be equal to u square will be equal to 1 by 4 pi epsilon naught into q square divided by m into r, okay. So this is the u square. So u will be equal to root of q square will be equal to q root 4 pi epsilon naught m into r, okay. it will be equal to the initial velocity, the minimum velocity. Okay, so the velocity should be greater than this part, which is equal to option number B.